Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have, this is a cubed square root is equals to square root of 27, and we solve this problem for all the values of a. So here we need to find all the roots of this equation. You see that this is cubic equation, so we find all the cube roots of this equation. So here first we need to remove the square root sign from both of the sides. So for this we will take a squaring on both of the sides, and we get here square root of a cubed and its whole square is equals to square root of 27 and its whole square. And now further in the next step we need more simplifications here, and we get this 2 and this 2 and square root are gone, and we get here a cubed is equals to this 2 and this square root are gone, and we get here 27. And now further in the next step we need more simplifications, and we will get here a cubed, and now we move the term 27 from right hand side to the left hand side, and it will becomes a cubed minus 27, and this whole equation is equals to 0. So now we rewrite this equation as in this form. This is a cubed minus, we write this 27 as 3 cubed, and this whole equation is equals to 0. And now in the next step we use here the nice cubic formula. You know about that. If we have x cubed minus y cubed is equals to x minus y times of x square plus xy plus y square. According to this nice formula, we write the above equation as in this form. So you see that the base of this term is our x and the base of this term is our y, so that when we substitute the values of x and y in this formula, it will be written as the first factor is x minus y, the value of x is a minus the value of y is 3 into this is x square. So here when we put the value of x, it will be written as a square plus this is xy, the value of x is a, and the value of y is 3 plus y square, the value of y is 3 square, and this whole equation is equals to 0. And now in the next step we need to divide this equation into the two cases. The first case is we write a minus 3 is equals to 0, and the second case is we write a square plus 3a plus this 3 square becomes 9, and this whole equation is equals to 0. And now here in the next step we move the term minus 3 to the right hand side, and we get the value of a is equals to 3. So this is the first root of the given equation, and now in order to find the other roots we need to solve this quadratic equation. So for this we need to use the quadratic formula here, and for this we first write the coefficients of this equation, and its coefficients are capital A is equals to 1, capital B is equals to 3, and capital C is equals to 9. And we state the quadratic formula as a is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So we substitute all the values of a, b and c here, so it will be written as a is equals to this is minus b, the value of b is 3, so it will becomes minus 3 plus minus square root of b square, b is 3 square minus 4 times of a is 1, and c is 9, and it is divided by 2 times of a, and here our a is equals to 1. And now in the next step we need more simplifications here, and it will be written as minus 3 plus minus square root of this is 3 square becomes 9 minus 4 times of 9, and it is divided by 2 times of 1 is equals to 2. So further we need more simplifications here, and we will get this is minus 3 plus minus, here we need to focus inside the square root sign, and here we will take common and 9, and we get the remaining values are 1 minus 4, and it is divided by 2. And in the next step here we need more simplifications, and we get our a is equals to minus 3 plus minus, here we apply the square root separately on both of these two values, and we get here square root of 9 into square root of 1 minus 4, and it is divided by 2. And further in the next step we need more simplifications here, and we get this is minus 3 plus minus, here we know that the square root of 9 becomes here 3 into square root of 1 minus 4, and 1 minus 4 becomes minus 3, and it is divided by 2. And now here in the next step we have, this is minus 3 plus minus 3 times. Here we apply square root separately on both of these two values, and we get here square root of 3 into square root of minus 1, and it is divided by 2. And now here in the final step, we will obtain minus 3 plus minus 3 times of square root of 3. And we know about that, when negative sign appears inside the square root sign, so this will becomes here iota, and it is divided by 2. So these are the two complex roots of the given equation. And finally we have, there are three roots of the given equation in which these two roots are complex roots, and a is equals to 3b, the only one real root of the given equation. So these are the three roots, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.